Of all the reflexes hardwired into the human nervous system, the most immediate and, arguably, the most paradoxical is the scream. When you slam your finger in a door, when you slip and hit your tailbone, or when you touch a stove burner, the reaction is not a silent, controlled gasp. It is a sudden, involuntary, loud, and high-pitched noise. It is an alarm that rips out of your lungs before your conscious mind even registers the word pain. But stop for a moment and consider this reflex from an evolutionary standpoint. Why? Why would nature build a defense mechanism that involves drawing attention to yourself at your most vulnerable moment? In the wild, a loud shriek attracts predators, alerts rivals, and destroys your element of surprise. From a survival perspective, the most logical response to sudden trauma should be silence, followed by rapid flight or defense. Yet, our brain chooses noise. The reason is that the scream is not primarily a communication tool. It is a biological tool of self-preservation that operates on two profound interconnected levels. It is a high-speed override designed to hijack your central nervous system, and it is the fastest way for your body to administer a massive dose of its own internal opioid anesthetic. Your scream is not a sign of weakness or distress. It is your body's most effective, aggressive, and ancient painkiller. And to understand why we choose such a violent sound to cope with trauma, we have to deconstruct the neurobiology of pain masking, a concept rooted in the revolutionary gate control theory. Before diving into the complex mechanisms, let's define the key difference between an expression of pain and a functional painkiller. An expression of pain, a groan, a tear, a whimper, is an after effect of the trauma signal reaching the brain. The scream, however, is a concurrent, competing signal. It is the central nervous system's lightning-fast countermeasure, designed to overwhelm the pain pathway the moment that pathway activates. The brain knows that a high-intensity, full-body sensory input can be used to redirect critical processing resources away from the location of the injury. The scream, by its very nature, is a powerful sensory explosion. It involves extreme muscular tension across the entire torso. The diaphragm, the abdominal muscles, the vocal cords, and the neck are all subjected to maximum force. This intense muscular contraction creates a massive, non-painful sensory signal that is instantly sent back to the spinal cord and brain. This is where the core principle of pain masking, the gate control theory, GCT, comes into play. Proposed by Ronald Melzack and Patrick Wall in 1965, the GCT revolutionized our understanding of pain. It moved pain processing from a simple one-way street, trauma brain, to a complex, multi-lane, adjustable highway. Imagine your spinal cord, which is the relay station between the injury and the brain, contains a set of neural gates. When these gates are open, pain signals flood up to the brain. When they are closed, the signals are inhibited, and the perception of pain is minimized. Pain signals are primarily transmitted by small, slow, unmyelinated nerve fibers, called C fibers. These fibers are like the slow, heavy trucks carrying the signal of trauma. They are what the brain registers as dull, throbbing, chronic pain. These signals try to open the gate. Conversely, the gates can be closed by signals traveling along large, fast, myelinated nerve fibers, called A-beta fibers. These fibers carry non-painful sensory information, pressure, touch, vibration. They are the high-speed race cars of the nervous system, and they try to close the gate. This is why your first, instant, non-thinking reaction to bumping your elbow is to immediately rub the spot. When you rub your elbow, you activate the fast A-beta fibers, which rush to the spinal gate and slam it shut before the slow-moving pain signal carried by the C fibers can get through. You are using a massive, non-painful input touch to override the painful input. The scream is simply the most aggressive internal application of this exact same principle. The act of screaming, the forceful contraction of the muscles, the sudden expulsion of air, the tension in the chest sends a huge, rapid surge of non-painful mechanoreceptor data through those fast A-beta fibers. This surge creates a sensory traffic jam at the spinal gate, effectively forcing the gate to close and blocking the main bulk of the incoming pain signal. The loud, Sharp sound itself provides the final layer of sensory distraction, making the brain focus on the urgent sound response rather than the injury location. The scream is a forced internal rub, a desperate attempt to close the gate and buy the brain critical seconds of reduced perception. While the gate control theory explains the immediate, mechanical masking of the pain signal, it doesn't account for the profound analgesic effect that screaming actually has on the brain's chemistry. This is where the deeper, more powerful defense mechanism, the chemical self-medication, comes into play. The intensity of a sudden, unexpected scream is interpreted by the brain as an event of extreme, life-threatening stress. This stress response instantly activates one of the most vital structures in the brainstem, the periaqueductal gray. Image illustrating the location of the periaqueductal gray in the brainstem. The PAG is essentially the brain's command center for pain control and defensive behavior. When activated by severe sensory input like a scream or a panic response, the PAG triggers a descending inhibitory pathway, a direct line that runs down the spinal cord to suppress pain signals. To execute this suppression, the PAG releases a chemical cocktail of powerful natural painkillers, endogenous opioids, primarily endorphins and enkephalins. Endorphins are the body's natural version of morphine or fentanyl. They are rapidly released into the bloodstream and, critically, into the cerebrospinal fluid, where they bind to opioid receptors located on the nerve terminals in the spinal cord. When the endorphins bind to these receptors, they physically block the release of substance P, which is the primary neurotransmitter that transmits the pain signal across the synapse. The result is a powerful, instantaneous rush of internally produced analgesia, known as stress-induced analgesia, SIA. The scream, as an act of immediate, violent stress, is one of the fastest and most reliable ways to trigger this endorphin dump. Studies have shown that a person can tolerate significantly more pain when they are actively and loudly vocalizing compared to when they are enduring the pain silently. This is because the vocalization itself is the activation signal for the PAG to release its chemical bomb. This biological imperative explains why soldiers on the battlefield often report feeling no pain immediately after a traumatic injury, or why athletes can finish a game with a broken bone. Their system has been so overwhelmed by the stress of the event that the PAG has initiated a full-scale opioid blockade. The scream simply serves as the most immediate psychological and physiological trigger for this life-saving process. It provides a momentary, self-administered anesthetic that buys the individual time to assess the damage, find safety, or initiate a fight-or-flight response without being crippled by the pain. The mechanism is so reliable that it has a profound effect on the victim's interaction with the environment and with other people. While the primary function of the scream is internal, self-medication, it has an essential secondary, social function that is intricately regulated by the brain. Screams are universally recognized by the human brain in a unique way. Research using fMRI technology has shown that screams occupy a specific acoustic niche. Unlike normal speech, which typically has a frequency between 4 and 5 Hz, screams, especially those expressing fear or pain, have a highly modulated frequency between 30 and 150 Hz, a phenomenon called acoustic roughness. This acoustic roughness instantly and preferentially activates the amygdala, the brain's fear and danger center. This rapid, non-linguistic activation means that a scream bypasses the normal auditory processing centers, hitting the primal fear center directly. This is why a sudden scream is so jarring and attention-grabbing. It is biologically encoded to be impossible to ignore. However, the brain's use of the scream is context-dependent. Studies have demonstrated that people are more likely to suppress their vocalization when they know they are not alone or when they are in a social setting where expressing pain might be penalized or judged. Conversely, people tend to scream louder and more frequently when they are alone and feel truly vulnerable. This suggests a crucial point. The brain weighs the risk, attracting predators, social judgment, against the reward, immediate pain relief, summoning help. When no help is available and no predators are near, the internal analgesic function is prioritized, leading to the loudest, most cathartic release. The social function also acts as a powerful threat signal. The scream not only alerts companions but can also startle a small predator or an attacker, initiating a brief moment of hesitation that is often the difference between life and death. In this way, the scream serves as a universal, nonverbal distress code that is faster than any language and more persuasive than any plea. The reflexive, involuntary scream that erupts when you are hurt is a profound example of the body using its own internal processes to manage crisis. It is not an emotional outburst, but an elegant biological hack that operates on 3 coordinated levels. Gate control override. The intense muscle activity associated with screaming floods the spinal cord with fast, non-painful sensory signals, temporarily closing the neural gates and blocking the ascending pain message. Chemical analgesia. The stress of the violent vocalization activates the periaqueductal gray, triggering a rapid dump of powerful endorphins and enkephalins, which chemically suppress the transmission of pain neurotransmitters in the spinal cord. Attention redirection. The sheer force and acoustic roughness of the scream instantly redirect the brain's focus away from the source of the trauma, buying critical seconds for the conscious mind to formulate a survival strategy. The reflex to scream when hurt is not a flaw in our evolution. It is a testament to the complex, self-regulating brilliance of the human nervous system. Your scream is the fastest, most effective, and most profound act of self-medication available to you. It is a violent, necessary response that ensures survival by minimizing the sensory input of pain and maximizing the biological counter-response. In a world full of pain, the human brain built a defense mechanism that literally uses noise to create silence. The next time you witness a scream of pain, remember that you are not looking at a victim. You are looking at a highly evolved biological machine, aggressively hacking its own system to administer a dose of internal anesthetic, ensuring its continuity and survival.